This will be part 1 of lesson 3. The lesson is on exploring the X and Y intercepts and interpreting relations. So just a quick review of a bit of lesson 1 and a bit of lesson 2. We talked about ordered pairs, and ordered pairs are always X comma Y. They lie on a Cartesian plane. So a Cartesian plane, the horizontal axis is what we call our x-axis, and the vertical axis is our y-axis. And then in the last lesson, we learned that the x values are what we call our inputs, and the y values are our outputs. As well, the x values are what we call our independent variable, and the y value is our dependent variable. So essentially, the y depends on whatever you input for the x, okay? A relation is a connection between two quantities, so x's and y's. A relation can be represented graphically by a set of ordered pairs. Right? So time goes on the x-axis and money goes on the y-axis. It's a relationship between two quantities, and I could graph that. The first component of a set of ordered pairs is so what's the first component? That is the x coordinate, and it is also known as the input. Inputs are values of the independent variable. So inputs are independent, I and I. The second component of a set of ordered pairs is the y-coordinate. It's also known as the output. So when you input an x value, the y spits out, and the y values are the dependent. Okay, so all of this you should know like the back of your hand by the time you get to this lesson and have done the previous homework. Okay, what we're going to do now is we're going to explore the x and the y-intercepts. So whenever you have a graph, if it cuts the x-axis, that is going to be an x-intercept. So on my graph, this is my graph here, this blue line, and where it cuts on the x-axis is an x-intercept. Where your graph cuts on the y-axis is a y-intercept. Okay, and depending on your graph, you could have more than one x-intercept or more than one y-intercept. So what it says for A, list the coordinates of the points where each graph cuts the x-axis. So I'm going to put big red dots where it cuts the x-axis. That's an x-intercept, and it's at -3, 0. These two coordinates here are where my graph cuts the x-axis. Those are x-intercepts. So the first one is -2, 0, and then 3, 0. This point and this point is where my graph cuts the x-axis, because remember that's my x-axis. So that would be -4, 0, and 4, 0. Okay, now what do you notice about all of these ordered pairs? Like what's similar? And what you should note is look at the y values. If we have an x-intercept, the y coordinate will always be 0. So for example, like later on, if I said, okay, the point -7, 0, what is this point? And you would say, oh, the y is equal to 0, therefore, this x value of -7, it's what we call an x-intercept. So this graph would cut the x-axis at -7, 0, and it would cut the x-intercept would be -7. Okay, so what do all the points have in common? The y-coordinate is 0. So the y-coordinate is 0. Okay, let's look at C. So I'm going to erase these points. And now what we're going to look at is we're going to get all of the ordered pairs of all of our y-intercepts. So where does each graph cut the y-axis? So for example, on graph 1, that would be this point here. On graph 2, it'd be this point, and I've got 2 y-intercepts on graph 3. I'm going to find the first point with you. That point, remember that it is always x comma y. So I have to say, well, what's my x value? What's my y value at that point? My x value at that point is 0, and my y is 5. So 0 comma 5. I want you to pause this for a minute, and I want you guys to get that coordinate for me, this coordinate, and this coordinate on graph 3. So just take a minute, pause it, get those coordinates, and then we'll talk about what we notice. Okay, the coordinates that you should have gotten, graph 2 crosses the y-axis at 0, 6. Graph 3 crosses the y-axis at 0, -4 and 0, 4. So what do we notice about all of the coordinates which have y-intercepts? Well, boom, 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 boom. All x values are 0. So what we're going to deduce from this later on is if I gave you the point 0, 25 and I said, well, what is this? You would say, oh, 0, 25, y and x is 0, y is 25. That is a y-intercept, right? If x is 0, the y-intercept is equal to 25. It would be a point right here at 0, 25. So what do all points have in common from C? All x coordinates are 0. Are 0. Okay. X and Y intercepts of your graph. We're going to do class examples 1 and 2, and then I will give you some time to do homework. So what is this? Sorry, I'm just trying to figure out where I've got my work. So this looks like class example number 1. And let me see if I have number 2 on here. I've got it down here. Okay. So class example number 1. They give us an equation. 3y is equal to 5x plus 15. So the first thing that we need to do is in order to find your x-intercepts. Okay, so one of the things that I need you to understand, maybe that's why I have this space here. So just somewhere off to the side, here's what I want you to do. Label y and label x. And an x-intercept is where our graph cuts the x-axis. So that would be an x-intercept. And what you need to realize for an x-intercept is that if you're solving for an x-intercept, y is equal to 0, right? So let's say that that value was 1, 2, 3. That point would be 3, 0. That would be my x-intercept. X would be equal to 3. And that would be my y value. For all x-intercepts, y is equal to 0. So in the next example, when I say, what's your x-intercept? What we're going to do is we're going to let y equal 0. Likewise, for y-intercepts, so there's y, there's x. Let's say my graph does this, and that's my y-intercept there. So let's say that point is 1, 2, 3, 4. X is 0, y is 4. So if it's a y-intercept, x is always equal to 0. Okay, so if I say solve for an x-intercept, y is equal to 0. Solve for an x-intercept, or sorry, y-intercept, x is equal to 0. So now, going back to this question here, They give us an equation and they say, well, what would the x and the y-intercept of this graph be? So I want you to write the equation under each one. So 3y is equal to 5x plus 15, and 3y is equal to 5x plus 15. If I say, what is the y-intercept? You let x equal 0. And if I say, well, what's the x-intercept? You let y equal 0. So if I ask you to solve for x, you let the other letter, which is y, equal 0. So let's figure out what the x-intercept is. 3 times 0 is equal to 5x plus 15. 0 is equal to 5x plus 15. We need to isolate this 5x, so subtract 15 from both sides. Negative 15 is equal to 5x. Now we need to isolate the x. X is being multiplied by 5. The opposite is divide by 5. X is equal to negative 3. That, you guys, is my x-intercept. The ordered pair would be negative 3, comma, 0. So if I said graph that, y and x-intercept, my graph, is at negative 3 and y is 0. That is my x-intercept on this equation. Now, what's the y-intercept? We're going to do the exact same thing, except now we're going to let x equal to 0. So here's my x, put a 0 in there. 3y is equal to 5 times 0 plus 15. 3y is equal to 0 plus 15. 3y is equal to 15. Isolate y by dividing by 3, and y is equal to 5. That, you guys, is my y-intercept. What is the ordered pair, though? It's always x comma y. X is 0, and y is 5. So x is 0, 2, 3, 4, y is 5. There's my y-intercept. As long as you have 2 points, that's the minimum amount of points you need, and I could draw this graph. Because I simply connect those 2 points. There's my graph. Draw an arrowhead at the end of each line. And the equation of this graph is 3y is equal to 5x plus 15. Okay. For class example 2, I don't want to use the example that they gave because it has squares in it, and linear relations, the degree is 1. So I just want to deal with x to the power of 1. So what I want you to do for this one, can you cross out these? And let's do this example here. 2y plus 3x minus 12 is equal to 0. So if I give you that equation there, and I say, well, what are the x and y intercepts? You say, no problem. Write the equation for each one. So 3x minus 12 equals 0. Okay, so write your equation for each one, and then say, okay, she wants the x-intercept. What letter do I let equal 0? Y. If she wants the y-intercept, you let the opposite letter, which would be x, equal to 0, and you solve. So the x-intercept, I'm going to let y equal to 0. So there's my y. Two times 0 is 0. I don't even need to write that down, right? And I've got 3x minus 12 is equal to 0. I need to first isolate that 3x, so get rid of that negative 12 by adding 12 to both sides. Divide by 3, divide by 3. X is equal to 4. That is my x-intercept. My ordered pair, remember it's always x comma y. So if x is 4, if it's an intercept, y we said was 0. I'm going to get you to graph this. So there's my y, here's my x. I got my x-intercept is 4. 1, 2, 3, 4. So it cuts the x-axis at 4. Now let's figure out the y-axis. So basically, it's got to go through this point, and my graph's either going to go in that direction or it's going to go down here, right? Where is my graph going to cut the y-axis? So to figure out the y-intercept, you let x equal to 0. So this guy's going to be equal to 0. So 2y plus 3 times 0 minus 12 is equal to 0. 3 times 0 is 0. I'm just going to get rid of it. 2y minus 12 is equal to 0. We need to isolate that 2y, add 12 to both sides. 2y is equal to 12. Now we've got to isolate y, get rid of that 2 by dividing both sides by 2. Y is equal to 6. That is your y coordinate. When x is 0, y is 6, right? This is your y-intercept. Is equal to 6. So going back to my grid, 1, 2, 3, 4, 5, 6. At 6, there's my y-intercept. So I'm going to draw my line, and there would be my graph. Extend the tail, or put an arrowhead on each side of your line to show that it will continue forever going up and to the left and down and to the right. But that's how you find your intercepts. Okay, I'm going to give you this, you guys, is this idea of calculating x and y intercepts. Very important to be able to do and to be able to understand. Okay, what do I have here? A lot. Okay, homework. So number 1, circle. 2, A, B, C, and F. 3, A, B, C, F, and I say fractions are okay. Do number 3 as a class. So let's just look at the homework really quickly. 1, 2, and 3. Let's have a look at this so that I could set you up. Okay, so number 1, just let me have a quick look at this and flip mine over. Okay, number 1, I don't want you to do F because it's got a squared in it and we don't need to deal with squares. What it says is determine the value of the y-intercept, okay? So is all I want to know is what's the y-intercept. If I'm asking you to calculate the y-intercept, what letter equals 0? X. So all you're doing for this one is for each one you're letting x equal 0. So y is equal to 0 minus 5. Y is equal to negative 5. That is your y-intercept. So my y-intercept is equal to negative 5. You should also know how to write that as an ordered pair. If x is 0, y is negative 5. Okay, that's all I want you to do for number 1 is just calculate the y-intercept by letting x equal 0. Number 2, I want you to do all of these except for E. And what we're doing for number 2 is we're calculating the x-intercepts. So what letter do we let equal 0 if we're calculating the x-intercept? So if you were in class, I'd be like, raise your hand. Okay, y is equal to 0. If you're calculating x, let y is equal to 0. So 0 is equal to x minus 2, and we have to solve for x. So add 2 to both sides, and the x-intercept is equal to 2. And that would be my ordered pair, right? For this one, if y was 0, you'd say, okay, 3 times 0 is 0. 2x minus 12 is equal to 0. Solve for x. Add 12 to both sides. X is equal to 6. That's your x-intercept. Your ordered pair would be 6, 0. So if you guys could finish that off for D, for F, and for B. Number 3, I want you to do B, C, and F. I will do A with you. So A says determine the X and Y intercepts of each equation, answers as ordered pairs. So when we're doing the X and Y intercepts, what I want you to do is I want you to split this and I want you to write X-intercept here and Y-intercept here. If you're doing the X-intercept, remember you let the opposite letter equal 0. And if we're doing the Y-intercept, let X equal 0. Okay, solving for the Y-intercept, I'm going to put, the X-intercept, 0 is equal to 4x plus 7. And I need to isolate that 4x, so subtract 7 from both sides. Negative 7 is equal to 4x. X is equal to negative 7 over 4. And that as an ordered pair, x is negative 7 over 4 and y is 0. So your book keeps it as fractions, so I'm going to keep it as a fraction. It's really hard for students, though, to see, like, well, where is negative 7 over 4? Negative 7 over 4, that's the same thing as negative 1.75. So it's not quite at negative 2, right? If I said plot that, you would say, okay, um, here's negative 1, negative 2, negative 1.75 might be right about there, okay? And then if we were doing the y-intercept, you let x equal to 0. So y is equal to 4 times 0 plus 7. Anything times 0 is 0. Y is equal to 7. So my ordered pair would be 0, comma 7. So if that's 7, that would be my ordered pair, and my graph would look something like that. You guys could do B, C, and F. And then just let me look at question 4 and 6. No, that will be part 2. Okay, so once you finish F, you could watch part 2 of lesson 3.